Morning students, welcome to the Science 1 class. Today we are going to learn about Unit 6 Light. Children, we all know about light. Light is a form of energy which travels as electromagnetic waves. The branch of physics that deals with the properties and applications of light is called optics. In our day-to-day life, we use number of optical instruments. Microscopes are inevitable in science laboratories like telescope, binoculars, cameras are used to educational, scientific and entertainment fields. In this lesson, we are going to learn about spherical mirrors like concave, convex, and also we are going to learn about the properties of light, reflection, and refraction and their applications. Let's start with the topic reflection of light. Light falls on any polished surface such as a mirror reflected. This reflection of light on polished surface is follows certain laws, and you have studied about in your lower classes. Let us study about little elaborately here. Consider a plane mirror M dash that is shown in the figure. Let AO be the light ray incident on the plane mirror at O. The ray AO is called incident ray. The plane mirror reflects the incident ray along OB. The ray OB is called reflected ray. Draw a line on at O perpendicular to M and M dash. This line ON is called what? Normal line. The angle named by the incident ray with the normal, that is angle I, that is I is equal to angle AON, is called angle of incidence. The reflected ray OB makes an angle R is equal to NOB with the normal, and this is called what? Angle of reflection. From this figure, we can observe that the angle of incidence is equal to the angle of reflection. So we can write angle I is equal to angle R. Also, the incident ray and the reflected ray in normal at the point of incidence, all lines are lying same plane. These are called the laws of reflection. What are the laws of reflection? The incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. When you see the diagram, you can able to understand the angle of incidence is equal to angle of reflection. These are the laws of reflection. You might have heard about inversion. But what is lateral inversion? The word lateral derived from Latin word latus, which means side. Lateral inversion means sidewise inversion. It is the apparent inversion of left and right that occurs in a plane mirror. Why do plane mirror reverse left and right, but they do not reverse up and down? The answer is surprising. Mirrors do not actually reverse left and right, and they do not reverse up and down also. What actually mirrors do it inside out? Look at the image below and observe the arrows which indicates the light ray from the object falling on the mirror. The arrow from the object is directed to go the top of the mirror, and the arrow from the feet is directed towards the bottom. The arrow from the left hand goes to the left side of the mirror, and the arrow from the right hand goes to the right side of the mirror. Here you can see that there is no switching, it is an optical illusion. Thus, the apparent lateral inversion we observe is not caused by the mirror, by the result of our perception. What is real and virtual image? If the light rays coming from an object actually meet after reflection, the image formed will be a real image, and it is always inverted. A real image can be produced on a screen when the light rays coming from an object do not actually meet but appear to meet. When produced backwards, the image will be virtual image. The virtual image is always erect and cannot be caught on the screen. We studied about laws of reflection. These laws are applicable to all types of reflecting surfaces including curved surface. In our earlier classes, you have studied that there are many types of curved mirrors such as spherical, parabolic mirrors. The most commonly used type of curved mirror is spherical. Spherical mirrors. In curved mirrors, the reflecting surface can be considered to form a part of the surface of a sphere. Such mirror whose reflecting surfaces are spherical mirrors. In some spherical mirrors, the reflecting surface is curved inverse, that is, it faces towards the center of the sphere. They are called concave mirrors. In some other mirror, the refracting surface is curved outwards. They are called convex mirror. Image formed by spherical mirrors. In the case of plane mirrors, we use only two rays to understand how to get full image of a person. For understanding the nature of image formed by spherical mirror, we need to look at four specific rules. Let's see all the four specific rules. Rules for the construction of image. To find the position and nature of the image formed by a spherical mirror, we need to know the following rules. Rule 1. A ray passing through the center of curvature is reflected back along its own path. That is shown in the figure. The center of curvature is represented by the letter C and focus point is represented by F and P is the pole. Okay. Rule 2. A ray parallel to the principal axis passes through or appears to be coming from the principal focus after reflection. When you see this ray diagram, we can able to understand the middle line is called what? Principal axis. So a ray is parallel to the principal axis. After touching that mirror, it reflects back through principal focus, that is represented through the letter F. This is what rule 2. Rule 3. A ray passing through the focus get reflected and travels parallel to the principal axis. So here in the ray diagram, a ray is passing through the principal focus. So after touching that mirror, it's reflected back parallel to the principal axis. So when a ray is parallel to principal axis, it reflects back through principal focus. When a ray parallel through a principal focus, it's reflected back to parallel to the principal axis. Rule 4. A ray incident at the pole of the mirror gets reflected along a path such that the angle of incidence APC is equal to the angle of reflection BPC. Here, when you can see this diagram, we can able to understand a ray passes and reaches at the pole and reflect back. So these incident ray and reflected rays makes an equal angle, that is APC is what? Incident ray and BP is called reflected ray. So angle I is equal to angle R. Now let's learn image formation by concave mirror. We shall now find the position, size and nature of the image by drawing the ray diagram for small linear object placed on the principal axis of the concave mirror at different position. Case 1. When the object is far away at the infinity, the rays of light reaching the concave mirror are parallel to each other. So, position of the image is formed at the principal focus F. Nature of the image, it is real, inverted and highly diminished in size. Case 2. When the object is beyond the center of curvature, here the object is placed O and O dash, that is what object where they kept it is beyond the center of curvature C. Is center of curvature, so the position of the image will be formed between the principal focus F and center of curvature C. Where the image formed between center of curvature C and principal focus F. Now the nature of image is real, inverted and smaller than object. In case 3, when the object is at center of curvature, where the object is placed on the center of curvature C. Now the position of image is at the center of curvature itself. Okay, same place the image also formed. Nature of the image is real, inverted and same size as the object. So, I and I dash represented what? Image, it is downwards. O dash is the object. Case 4. When the object is in between the center of curvature C and principal focus F, position of the image is formed beyond C. I dash is the image. So, nature of the image is what? Real, inverted, magnified. Case 5. When the object is at the principal focus F, object is kept on the principal focus F. Nature of the image, no image can be captured on the screen or any virtual image can be seen. Finally, case 6. When the object is in between focus F and the pole P, position of the image is called behind the mirror. Keep it in your mind. When the object is kept between focus and pole, the position of image is formed behind the mirror, not in front of the mirror. Nature of the image, it is virtual, erect and magnified. That's all today's class. Thank you students. Have a good day.